In PHP, there's different scripts you can there's different functions you can disallow. For instance, allow URL fopen and allow URL include. If you disable them, a lot of this functionality will go away. I actually wrote a script way back when. It would go out to IMDb, look up all the zombie films that I knew of, which are quite a few. Then it would automatically sort them. It's sort of a scraper script. And post whichever one was the most popular on the top, whichever one has highest star ratings. Unfortunately, I switched to DreamHost, and it's probably a good idea. They've disabled that functionality. Also, you want to turn off register globals. Register globals is a feature that people used to use a lot in PHP, where anything you submitted automatically became a variable inside of PHP, and this allowed people to modify variables before they were supposed to. By the way, a lot of these fixes, I'm just covering them in general. OWASP goes into great detail on their website on how to fix some of these. And ensure all file and stream functions are carefully vetted. All right, the next one is going to be a quick one. Insecure direct object reference. A direct object reference occurs when a developer exposes the reference to an internal implementation object, such as a file, directory, database record, or key as a URL or form parameter. Attackers can manipulate those references to access other objects without authorization. Well, no need for a demo on this one, because you've largely already seen it. A lot of times I was referencing files by their exact file name. That would be an example. I'm not sure if they considered the database name popping up in that error message as being an example. User ID is essentially thrown in the cookie. There's various things I do for internal implementation that I'm throwing out to the end user. So I violate this all over the place with Mutillidae. All right, fixes for that. Avoid exposing your private object references to users whenever possible, such as primary keys or file names. Validate any private object reference extensively with a set known good approach. Once again, that goes into a lot of validating input. And verify authorization to all reference objects. Now, here's the final one, and we can all be done. And I think, quite frankly, one of the coolest. Cross-site request forgery. Now, I'm using the acronym CSRF. Some people, I guess maybe to keep it common with XSS, use XSRF. It's just the same thing. Essentially what it is, well, I'm going to use their definition. A CSRF attack forces a logged-on victim's browser to send a pre-authenticated request to a vulnerable web application, which then forces the victim's browser to perform a hostile action to the benefit of the attacker. CSRF can be as powerful as the web application that it attacks. That's not really a very useful definition in many ways. So I have an illustration here. Essentially what it is you've logged into a box and you have a session with it. Let's say I logged into Gmail. And let's say it had a cross-site request forgery vulnerability. Essentially, I've already established a session. That's part one. The next thing that happens, at some later point, the content that the attacker controls is requested. That's number two. For instance, let's say I go to Irongeek.com, and Irongeek.com is referencing back to Google, trying to do a cross-site request forgery. What happens is, my website returns something, and by the way, I'm not really that miscreant. This is just for illustration. It returns back, my website's completely safe. Despite what WebSense says at your workplace, my website's completely safe to visit. It throws back some content to the browser. That content in the client's browser makes a request back to, let's say, Google or wherever the target web app is. And since that client already has a session with wherever the target web app is, that request goes straight through, assuming they haven't implemented the proper security measures to keep it from happening. Now, here's a few simple examples of cross-site request forgery. The canonical example is to use an image. For instance, right here, you see this little image tag. Well, let's see what it references. It's not pointing to a GIF or a JPEG or a PNG. It's referencing a PHP file, and then it's doing a query, and it's using GET parameters to add this information. Essentially what this is doing is it's saying, go to this page, add to your blog, use this input, and say, hi there, monkey boy. By the way, the %20s, that's a way of URL encoding spaces. Now let's say someone was to actually inject that. Let me go back up to my page. Let me see. Add to your blog. And I don't want to continue tampering. what I'm going to do is I'm actually going to inject that particular image. Now, keep in mind, this is technically not Crosssite request forgery because I'm doing it from the same site. There's a different term for that. But it looks largely in the same way. If I was to put this image tag on Irongeek.com and visit it, it would come back and edit this page. But let's say, and this is probably in some way how the Sammy worm worked a while back on one of the social networks. Let's say I'm logged in as Adrian, and I submit this. And essentially, there's a little image tag in there that you can't actually see. At least that's assuming I inserted it correctly. Yeah, it looks like I did. All right. Now I'm going to log out, and I'm going to log in now as John. Now that I'm logged in as John, I can go in and I can add to my blog. Currently, I only have a couple posts there. Chocolate is good as the very last one. But I want to check out some of my buddies' blogs. So I'm going to view someone else's blog, and I'm going to view Adrian's blog. Let's see what Adrian's been up to. Adrian's been up to not a whole lot. Oh well, and in reality, I probably should have put some more information there so it doesn't look as suspicious. But now John goes, well, okay, I've checked out my other buddies' blogs. I'm going to go back to add to my blog. I don't remember putting that there. That's one example. A couple of examples of cross-site request forgery. This one, let me go back to my presentation. That one is using an image tag. However, not everybody is going to necessarily accept GET requests. You can't necessarily always use GET, which is putting it in the URL, to actually submit something to a vulnerable application. Sometimes you may have to use POST, or sometimes you can't use an image at all. If you don't use an image at all, but you still want to use GET, you can use an iframe tag, which is essentially putting a web page inside of a web page, and make a request like that, and that will work just fine. And for example, if I was to swap back out here, and I believe I have a directory someplace or another called Crosssite Scripting Fun. That's the image one, which I already showed. And right there, I ran it, and I'm not from the website, but it's still going to submit that data into the database. For instance, if I was to refresh this, you see those two hide monkey boys. That's because that other HTML file I just opened has that same image tag. Let's do one of the other fun ones. Let's say I was going to use the post method. Actually, I don't think I actually illustrated that one. Take it on faith, that iframe one will work, and it's another option besides using an image tag. But sometimes people won't let you use GET. You can't actually put it in the URL. You have to submit it via post data. Well, how do you get post data to go? Well, there is a way. Once again, you do use an iframe, and you do use some JavaScript. I have a couple scripts here. This one is called CSRF post. I'm going to go ahead and open it up. Real work is done in iframe post.html. That's all it says. I could have put that script out on my website, and let's say John visited it at some point in time. Well, let me go back to John's blog and see what's there now. Test of auto-submitted form. Apparently, I proofread my code better than I proofread my prose. But you see, it did work, and here's how it worked. If I was to jump back out and look at CSRF post, by the way, who here uses Notepad++? If you're editing on Windows, Notepad++ just rocks. It's awesome stuff. Anyway, what it does is in an iframe, it references this HTML file. And the reason I do this is if I didn't, as soon as that HTML file came up, it would automatically redirect to the place it's posting data to. I obviously don't want that to happen. So let me go look at iframe post.html, where the real action is happening. What it does is it runs, first of all, it has this little form with a bunch of hidden variables, because I don't really need to show them, that have the proper variable names and the data I want to submit. Then it runs this simple little script, and it tells the form to automatically submit itself. Now, if I was to open up this particular page directly, it doesn't automatically redirect, which is obviously not what I want. That's why I use the second page with an iframe. But that's a couple of ways of doing cross-site request forgery. Now, on this, I was just being annoying. I was basically